To give you a simple overview, the four aerodynamic forces are lift, thrust, drag, and weight. Lift and weight are the vertical forces, while thrust and drag are the horizontal forces. That's the 10-second summary version, so let's dive in deeper into each force. Let's first talk about lift. Lift is perhaps the most important force in aviation, since without it, no aircraft can leave the ground. Lift is a positive vertical force that pushes the aircraft upwards. How lift is created is such a complicated topic that this topic alone can be its own video, but to simplify, when at high speeds, the airfoil is designed to have high pressure below the airfoil compared to above it. Since air has the tendency to move from high pressure to low pressure areas, the air below the airfoil will want to go upwards, pushing the airfoil and consequently the entire aircraft upwards with it. However, you might be wondering, how does the aircraft get to high speeds in the first place? Well, this is where thrust comes in. Thrust is the positive horizontal force that pushes the aircraft forwards. This is most often created by some kind of engine, be it a propeller engine or a turbofan engine. All of these engines create thrust by pushing air backwards, and because Newton's third law of motion states that every action has an equal and opposite reaction, the air will have a reaction by pushing the aircraft forwards, creating thrust. And whenever the aircraft is going at a fast enough speed, the airfoil's shape is able to optimize for the required air pressure difference for it to create enough lift. Aircrafts need to be at a specific takeoff speed to be able to create enough lift to actually leave the ground. While this is dependent on the aircraft you're piloting, what always applies is the effect of drag. Drag is a negative horizontal force, and it is a force that will always exist as long as the aircraft is in motion. There are many types of drag that I'm not going to get into right now, but to put it simply, some types of drag can be optimized and lowered by design, while others are inevitable. Drag will slow down your aircraft, so it is best for pilots to fly in a way that minimizes the effect of drag to save time and fuel. And the final force to talk about is weight. Weight is a negative vertical force that is caused by gravity and it is constantly trying to pull your aircraft back to the ground. This is another force that is inevitable since it exists even when your aircraft is idling. Weight is a force that is dependent on the mass of the aircraft, so the bigger or heavier the aircraft, the more weight there is. When talking about these four forces, equilibrium is often also brought up. An aircraft is in equilibrium when all forces in one dimension are equal. So for example, when the aircraft's thrust is equal to its drag, then it's in horizontal equilibrium. When the aircraft's lift is equal to its weight, then it is in vertical equilibrium. And finally, when all forces cancel each other out, then the aircraft is in complete equilibrium, and the aircraft is essentially not moving in the middle of the sky. A common question on aviation tests is that if an idle aircraft on the ground is in complete equilibrium, and the answer is no. Although it might seem as though the aircraft is not moving, therefore the aircraft must be in equilibrium, weight is still in play, so there is still a negative vertical force at play, making the aircraft not in equilibrium.